Today, in this video lecture, we will see this numerical 7th on Euler's formula. First read this numerical. Calculate the crippling load of a strut which is made of a bar circular in section and 5 meter long and which is pin jointed at both ends. The same bar when freely supported gives midspan deflection of 10 mm with a load of 80 Newton at center. So our objective is to find this crippling load. And see this strut. I told you in our first lecture of this chapter that strut is nothing but it is structural member, and this strut carried compressive load, and this strut is usually small in length. So first, with the help of this numerical, first draw diagram. See, calculate the crippling load of a strut which is made up of a bar circular in section and 5 meter long. So this is bar circular in section and length is 5 meter. Which is pin jointed at both ends. The same bar when freely supported gives midspan deflection. So let us assume this bar reactions as like this. And see midspan deflection 10 mm with a load of 80 Newton at its center. So here it is 80 Newton load at its center. Center, that means this is 2.5 meter and this is 2.5 meter. And the deflection of that beam is like this, and this deflection is 10 mm. So first understand concept of this numerical. So in this numerical they are talking about that deflection. So and our objective is to finding this crippling load. So first understand crippling load formula. It is PC is equal to pi square modulus of elasticity into moment of inertia upon effective length square. So understand what we have in this formula. So we have this pi square. We all know that pi is 3.14 square. So this is constant, that's why we all know that. And this YLE also we know. How this YLE we know? See, this YLE they don't give us in numerical, but YLE we know that both ends pinned or hinged. So both ends hinged, that means effective length is equal to actual length, and actual length is 5 meters. So this YLE is nothing but the 5 meter. So calculate this EI. And how to calculate this EI? Because this EI is not given in this numerical. In this numerical they are talking about this deflection 10 mm, and understand that formula midspan deflection for simply supported beam with central point load. So this deflection formula is load into length cube divided by 48 into modulus of elasticity into moment of inertia. So we have this W is this 80 Newton, we have this L, L is this 5 meter, and we have this delta is this 10 mm. So by using that we will find this EI, and this EI we will put in this PC equation. So by that way we will get this PC. So delta is 10 mm is equal to W is 80 Newton, length is 5 meter, that means 5000 mm, and see cube of that length. Delta is 10 is equal to 80 into 5000 cube. W is equal to L into delta is equal to W into L cube. Delta is 10, W is 80, and L is 5000 divided by 48 into modulus of elasticity into moment of inertia. Understand this formula delta. Deflection is directly proportional to load, and deflection is also directly proportional to length. But see, this deflection is inversely proportional to modulus of elasticity and moment of inertia. That means if this modulus of elasticity will increase, this deflection will decrease. If this moment of inertia will increase, this deflection will decrease. So when modulus of elasticity and moment of inertia increases, deflection decreases. So calculate this EI mathematically. 10 into 48 divided by 80 into 5000 cube. It is 4.8 into 10 raised to minus 11. Wait. Calculate like this. This is not 4.8 into 10 raised to minus 11. Sorry for that. Just rearrange this mathematically. 10 into 48 into EI is equal to 80 into 5000 cube. So now calculate EI. Mathematically 80 into 5000 cube divided by 10 into 48, it is 2.084 into 10 raised to 10. And what is unit? I don't know unit. So how to know unit? Just calculate. See, this is deflection is in mm, this 80 is in Newton, this 5000 is in mm, so this is cube, so that's why mm cube. So this is in mm, this is in Newton, and this is in cube. So this this 1 cancel. So Newton square is unit. And by C, we all know that modulus of elasticity unit is Newton per mm square, and moment of inertia is mm raised to 4, mm raised to 4, mm raised to mm square gets cancelled, remaining is Newton mm square. So by that way also you can find this unit. So put this E value in this PC value, pi square EI upon LE square. So this PC is equal to pi square EI is 2.084 into 10 raised to 11. LE square is 5000 square. So this PC is pi square into 2.084 into 10 raised to 11 divided by 5000 square. So it is 10 raised to 11. Wait, calculate this again because this is not 10 raised to 11. 80 into 5000 cube divided by 10 into 48. It is 10 raised to 10. By mistake, it is written as 10 raised to 11. It is 10 raised to 10. So here also 10 raised to 10. So pi square into 2.084 into 10 raised to 10 divided by 5000 square. So it is 8227.30, and unit is Newton. This is buckling load. So this PC is equal to 82.27 kilonewton. See, this buckling load is very higher value, 82.27 kilonewton. That means it is 827 kg, 822.7 kg. So why this buckling load comes higher? Because there is one reason behind that. What is this? What is reason? Because this is strut, and strut is like generally short in length, and they are compressive force members. So maybe that is the reason behind that. In this 5 meter, yes, in numerical they told us that this is strut, but by seeing this 5 meter length, that there is doubt behind that question. Yeah, but solving methodology is correct if they are interested to find this crippling load and with the help of this deflection. So remember that this relation between deflection delta is equal to WL cube by 48 EI, and this PC. Generally PC, that crippling load and buckling load for Euler's formula is for which column? I told you that it is like theory of that Euler's column. This theory is not used for short column because the direct stress is considerable and hence cannot be neglected. So remember these formulas. Thank you very much.